Hello class, hope you had a good weekend. This week we're going to still stay in chapter 12, but we're going to look at the other part of chapter 12, which is rates of change. Last week all we looked at was mostly like stationary points, maximum and minimum. The other part of chapter 12 has to do with rates of change, so we're going to be using this formula. So this is the setup for every rate of change problem. You'll need to memorize this. Okay. This is using derivatives, so you're going to still use like chain rules, stuff like that. But rates of change doesn't really deal with stationary points anymore. Okay, so rate of change. So what does rate of change mean? So when we talk about what is the rate of change of something, we want to know how does one variable change due to another. And an example of this is think of your paycheck. How does the amount of your paycheck change based on how many hours you work? So how one affects the other. That's what a rate of change is. So when two things have some kind of relation to each other, and when one changes, it changes the other. In physics, as in reality, just like your paycheck, most stuff depends on time. Okay, so rate of change always refers to dt. Okay, so back in that equation where you see dt, that means rate of change. So this is rate of change of whatever y is, and this is the rate of change of whatever our x is. Okay, and then this is the derivative that we've been looking at all throughout chapter 6, chapter 7, chapter 12. The derivative of the function y with respect to the variable x. Okay, so that's how you're going to read this. This is the rate of change of y, whatever y means. This is the rate of change of x. And then this is the derivative of the function y with respect to x. Okay, or you can read this as y's rate of change and x's rate of change. But that's how you read these, or that's what you need to think of anytime you see those in a problem. So the key to solving any rate of change problem, well, there's your formula again. So this is very important. This is the only thing you have to memorize for this part. The only equation really you need to memorize for derivatives, other than actually how to take a derivative. Okay, so like I told you, dy dt, that means rate of change of the y quantity, whatever that is, and rate of change of the x quantity. Now normally, if you think of an equation, the equation is normally y equals like mx plus b, or something with x in it. So y is normally your function, and x is the variable in the function. Okay, so that's one thing to make note of. So when you look at these problems, if you're given like an area problem, like some of those questions you did last week, find the area in terms of the volume, and you plug one into the other, that's the same thing. That's one of them was your y, whatever the outside, the parent function is your y, and whatever variables make it up is your x. Okay, so this is like the generic form, and then based on whatever your problem is, if you're using area, then you change y to a, and area depends on, like if you're talking about a circle, depends on radius. So y would be a and x would be like r, your radius. Or if you're talking about volume, y would be v, and then whatever volume depends on. Okay, so this is the generic form, and then you change it based on your equation, or based on your problem. Okay, so let's look at a problem then. So suppose, and this is how most of these rate of change problems are. They're going to be a paragraph basically. Good news is they're relatively easy once you learn how to pick out all the information. Okay, so that equation, all of this is in here somewhere. You just got to pull it out. One of these is what you're solving for. One of these is always given to you. And the other one, normally this one, is an equation you have to find to take the derivative of. Okay? So that's going to be the normal process for this. So today we're just going to look at an example. I want you to go through the example with me. And then tomorrow we're going to do another example, and then hopefully by then you'll be able to do one for an assignment. Okay, so suppose a spherical balloon is being inflated at a constant rate of 5 cubic meters per second. At a particular moment, the radius of the balloon is 4 meters. Find how fast the radius of the balloon is increasing at that moment. Okay, so first thing we know to do is go ahead and write down our rate of change. Okay, so that's the generic one, and I'm going to change this based on what we're doing here. So what are we talking about? Spherical balloons inflated constant rate, 5 cubic meters, so that's volume. Okay. So find how fast the radius of the balloon is increasing. So we're talking about volume. So Y is going to be our volume. dt never changes. Now what does volume depend on? Radius. So the volume depends on radius is like how Y depends on X. So X is going to be radius and Y is going to be volume. Okay, so putting it in that form helps you remember what these mean in words. It's going to help us pick this stuff out. So the rate of change of the volume. Okay, do we have that anywhere? So do we see, so first we want to look for the words rate or rate of change, something like that. So right here we have already constant rate. Anytime you see that word rate of 5 cubic meters. So what is this quantity they're giving us? Cubic meters, so that's volume. So this is the rate of volume. So that's this, remember, rate of change of volume. That's what they're giving us here. So instead of writing dV dt, I'm going to write 5. So that's what I meant when I said one of these is always given to you straight from the problem, just like that. So you're just replacing one of these with a number, and in this case it's going to be this one we're replacing with 5. Alright, dV dr. So that's the derivative of v with respect to r. Do we have an equation here? No. So you always need to look for an equation. There's no equation here, but they tell us which equation. A spherical balloon. And we're talking about volume. So we're talking about volume of a spherical balloon. So what is the formula or for volume of a sphere? So that's the equation. Now stuff like volume of a sphere, volume of a cube, they expect you to know that. If it's a weird shape, volume of a cone or something like that, they normally will give that to you. But just like they expect you to know area of a square, they expect you to know area of a cube, or area of a circle and volume of a sphere. Okay, if you don't remember, volume of a sphere is 4/3 pi r cubed. Okay, so V depends on R, see, because that's the formula. So that we got these right. So dV dr is just the derivative of V with respect to R. So we want to find V prime, or dV dr. So what's the derivative of this with respect to R? Well, bring the 3 down. So we get 3 times 4/3, 3's cancel. Pi and then subtract 1. Okay, so dV dr then is this. And so one's always given to us. One you find by taking the derivative of something, and the other one is the one you're trying to find. So find how fast the radius of the balloon is increasing at that moment. So how fast, remember that's time, how fast, that's rate, so that's dt of the radius. So dt of the radius, so that's what we're trying to find, dr dt. Okay, so we need to rearrange this for dr dt. So basically I'm just going to, this is multiplying, so I'm going to divide by the 4 pi r squared. So I get 5 divided by 4 pi r squared equals dr dt. Okay, now if I had a value for r, I could plug that in there and solve for dr dt. Am I given a value for r? Yeah, right here. So they'll always give you a value to plug in as well. At a particular moment, that's just saying we know at some point in inflating the balloon's radius was 4. And it's at that moment when its rate of change is 5. So we're going to use 4 in place of r. So we get 4 pi r squared equals dr dt. Okay, and you can just plug this into your calculator. 4 times 4 is 16, times 4 is 64. and you can just leave it like that. So that would be our answer. Okay, so hopefully it didn't sound too confusing. As we do more of these, you'll start to learn the pattern and the procedure, and it's always going to be the same. So you always start off with this equation, you change it based on what equations you have to use, and V depends on R, so replace Y with V, replace R, or replace X with R. One of them is always given to you, one you find by taking the derivative, and one is the one that you want to solve for. Okay, if you have questions, message me on Teams, and we'll do another example tomorrow. Thanks guys, have a great day.